So now, let's take this problem. Now, look at the following solid down there, which is a cylinder, as you can see. The base is a circle of radius r, and the height is h. And as you can see, the cylinder has no top. So I don't have any top cover here, but still I have the base down there. Now, imagine is the total surface of this given solid is 3 pi. The question is, find the maximum value of the volume of the solid. So, how can I solve it? As you know from geometry, the total surface is just the side surface plus the area of this base down there plus the area of this top above here. But since I don't have a top, I just have two surfaces to consider. First, the area of the base, which is pi r squared, and the area of the side surface, which is what? Good job. The side surface is 2 pi r times h. Now, if I already have the surface of the base, I mean the area of the base, and I have the area of the side surface, I conclude that the total surface area is, let's put them together, pi r squared plus 2 pi r h. And I already know what is this number. It's already given, which is 3 pi. So let's write it down. Now, what I'm looking for? I'm looking for a volume, as you can see, and I want to make this volume as big as I can. So let's make a function now, and here is the volume I'm looking for. And do you know what is the volume of cylinder? Good job. It's the area of the base times h. But what is the area of the base? As you can see, it's a circle, and the area of a circle is just pi r squared times the height is h. Now, how can I make this volume as big as I can? As you can see, this volume is a function of two variables again. I have r and h as my variables. So my job is to make everything in terms of r or everything in terms of h. But how can I do it? Look at the relation I have above. And let me put it inside this red box, because we're gonna need this relation between h and r to write one of these variables in terms of the other. So what do you suggest? What should I do? Yeah, maybe first I have to simplify it. As you can see, I have pi everywhere, so I'm going to divide everything by pi here and there. After that, what should I do? So I have one choice, which is to write r in terms of h or to write h in terms of r. What do you think is easier for us to do? Yeah, good job. As you can see, I can isolate my h here. So I can write everything on the right hand side. I already have 3 on the right hand side, so here is my 3. Also, I have r squared, I'm going to move it to the other side, minus r squared. Now, divide everything by 2r. Exactly. As you can see, I can write h in terms of r. So I'm going to need this new relation between h and r to plug it in my volume formula. Is that okay? Do you have any question, guys? Okay, if you don't have any question, we can move on to find what is the volume in terms of r. It's pi r squared multiplied by h, but h can be written as 3 minus r squared over 2r. As you can see, no problem to put r in my denominator because r is not negative, it's not 0. So I can just cancel r down and above. Can I simplify it more? Sure. Let me write my volume again. And here's my volume. As you can see, I have 1/2 at the beginning. And I have pi, another constant. Now I have r multiplied by 3 minus r squared. Maybe directly we can simplify it here. So I can write 3r minus r cubed. Here is my function, which is a function of one variable, r. What should I do next? Of course, I should find the derivative and put it equal to 0. Of course, we need more space, so allow me to clean here. I hope you already written this problem in your notebook. Now, I need to write this function again, simplified, before finding the derivative. So my function, as you can see, it's v equals to y over 2 multiplied by 3r minus r cubed. Here we are, 3r minus r cubed. I need to find the derivative, which is v prime equals to what? Let me first write my constant. And inside I have two terms. The first term, the derivative is 3, which is my coefficient here. The second term, the coefficient is 1 multiplied by the power of 3 multiplied by r squared. So here we go. Here is my derivative. I hope it's clear for you. And clearly, I have to solve the following equation. It's not a linear equation as before, but still we can solve it. It's a quadratic equation. And if I have number equal to 0, can y over 2 equal to 0, guys? Of course not. So inside here, I have something equal to 0. So let's solve it. 3 minus 3r squared equal to 0, which means I'm gonna have r squared equals to 1. What do you think my solutions will be? Yeah, maybe you will say I have r equals 1 and r equals negative 1, but can r be a negative number here?
No.
Clearly not. R cannot be a negative number because it represents the distance. It's the radius of my base. So I'm gonna have just one solution, which is r equals 1. Great. By the way, if r equals 1, what about h? Maybe you can return back to h here and you can plug r equals 1 down and up. What we can have in this case, 3 minus 1, yeah, 2 divided by 2, again it's 1. As you can see, in this case, also h equals to 1. So now I have my answer, r equals to 1, h equals to 1. I'm going to leave it to you to check if these values will give me a maximum or minimum. And after that, you can check that my volume in this case equals to what? Let me return back to my volume. My volume is pi r squared h. So the volume will be pi r squared h. So as you can see, pi multiplied by 1 equals to pi, which is the maximum volume I'm looking for. So can you check this volume is the maximum? Maybe I can give it as a homework for you. To check that this number will give me the maximum of the volume, not the minimum. So we already found the solution here. That was another application regarding geometry. I hope it's clear for you, but if you have any question, you can ask me now, guys. Any question? Okay, maybe that's enough for today, and I'm gonna see you guys next week. Have a good day. Bye-bye.
Bye.